we'll look into a few more examples and we'll solve them on you solve them on your notebooks and I'll solve them on the PowerPoint presentation. We'll try to cover different aspects of the thermodynamic tables that we have looked into. And so let's look at the first example. This is the example which says that a rigid tank contains 10 kg of water at 90 degrees centigrade. It further says that if 8 kg of the water is in liquid form and the rest is in vapor form, you have to determine number one, the pressure in the tank, and number two, the volume of the tank. Is it clear? Is the example clear?
Yes, sir.
All right. So how would we start solving this problem? We have to identify the table. How would we identify the table? Any idea how would we start with this problem?
सर आप थोड़ा सा बताएं फिर आगे हम बताते हैं.
आप यहाँ से देखें. The example says that you have 8 kg of the water in liquid form and the rest is in the vapor form. So what does it tell you about the state of your system? If liquid and vapor are coexisting, what does it tell you about the state of the system? If you remember, there are basically, if I draw this, let's say temperature specific volume plot. Number one, your system contains liquid. This is compressed liquid state, this is mixed state, and this is superheated vapor. Where do you have both of them coexisting together, liquid and vapors?
The
Boiling.
mixed state.
It is the mixed state in which both of them are coexisting together. And if you remember, in case of mixed states, you either refer to table A4 or you go to table A5. These are the tables that you refer to in case of mixed states. And since you are familiar that table A4 is basically the first column is of temperature and table A5 the first column is of pressure. So if you are given the data in terms of temperature, you will essentially refer to the table A4. Let's first see how the plot looks like. This is your state. This is your state where most of the system contains liquid and rest of it is vapors. 8 kgs in liquids and 2 kgs in vapor. And if you see the state is closer to the saturated liquid state. Why? Because you have most of it in the liquid form. Now you have to determine the first thing is pressure in the tank. And what is the pressure? This black line is a constant pressure line. So you have to find the pressure in the tank. And which pressure? Pressure refers to this state, which is essentially the pressure corresponding to T saturation. And T saturation is given to you as 90 degrees centigrade. So can you highlight the table that we have to look into and how would you find out the pressure in the tank?
सर A4 टेबल में 90 डिग्री सेल्सियस पे जो सामने प्रेशर आ रहा होगा वो प्रेशर हम लेंगे.
Very good. So you will go to table again, table A4.
70 point.
Very good. So you will go to table A4 and in table A4 you will highlight the temperature as 90 because you are referring to saturation temperature where both your liquid and vapors coexist. And for this temperature, 70.183 kilopascal would be your pressure. Clear enough? So P saturation at 90 degrees centigrade would be your pressure in the tank. The second thing is you have to find out the volume of the tank. Any idea how would you find out the volume in the tank? All right, there are two ways to do it. First one is that the total volume is equivalent to the volume of the liquid Vf plus the volume of the vapors, which is Vg. And volume of liquid is nothing but mass of liquid multiplied by the specific volume of the liquid plus mass of gas multiplied by the specific volume of the gas or vapor. Mass, both the masses are given to you. The only thing unknown is the specific volume of the liquid and the specific volume of the gas. The specific volume of the liquid is in front of 90 degrees centigrade, and similarly the specific volume of the vapor is in front of 90 degrees centigrade. So you will basically use this relationship to find out the total volume, mass multiplied by the specific volume of the corresponding state of your system. That means 8 kgs multiplied by specific volume of the liquid and 2 kgs multiplied by the specific volume of the vapor would give you the total volume of your system. Another way is you use the property known as quality, which is X. X, you know, is nothing but mass of vapor divided by the total mass. So X is essentially 2 divided by 10, which is nothing but zero point 0.2. So the first thing is you find out the quality. The next thing is you find out the specific volume of the mixture. Mixture would have a specific volume. So what is the specific volume of the mixture? It is V average. And the relationship for V average we have already deduced is nothing but specific volume of liquid plus X multiplied by VFG, which is the difference between the specific volume of vapor and gas. So you find out the average volume of your mixture. How? You take the VF from the table, you take the VFG from the table multiplied by the quality value, and you'll get the specific volume of your mixture. Once you know the specific volume of the mixture, can you find out the total volume?
So multiplied by 10.
Yes, multiply by
You will multiply it by the total weight. So specific volume multiplied by the mass would give you the total volume of your system. So this is the total volume of your system. Clear? Moving on, we have the next example. The next example would highlight two important aspects of the table. Let's first see what the example says. It says determine the temperature of water where the pressure is 0.5 megapascal and enthalpy is 2890 kilojoules per kg. The first thing for you is to identify the table. Any idea how would you identify the table?
So वही टेबल A4 यूज करेंगे.
प्रेशर दिया हुआ है
And
तो 5 यूज करेंगे.
sorry, table A4 यूज करेंगे. The data is given in terms of pressure.
सर 5 यूज करेंगे.
टेबल यूज करके क्या करेंगे?
सर प्रेशर जो दिया हुआ है इसके सामने वाला टेम्परेचर देखेंगे वो वाटर का टेम्परेचर होगा.
Do you know that this is a mixed state? There are three states: compressed liquid, mixed, and superheated vapor. Which of these states is governed by these two conditions? You don't know as yet. You have to
A5.
identify. All right, A5 यूज करके क्या करेंगे? Let's see how we'll do it. We have one thing that we have to do is identify the table. The second aspect is basically related to interpolation. Interpolation means that if some data is not given to you, the table that is being tabulated for you, if the value does not exist in the table, exact value does not exist in the table, how would you find out the corresponding properties? Let's see. So the two important things is one to identify the region, and the second thing is interpolation, which is related to finding the exact value. How would you do that? So the first thing, how would you identify the region? You'll go to saturated water pressure table, which is table A5 for zero point 0.5 megapascal or 500 kilopascal. The value given to you of enthalpy is 2890 kilojoules per kg. Now, if you see the enthalpy values, you would see that for saturated liquid, enthalpy value is 640.90. For saturated vapor, it is 2748.1. 2890 doesn't lie in the table. How would this help me to identify the region? The enthalpy value is 2890, which is essentially greater than your Hg value, which is 2748.1. What does this tell you about the region in which your system is in? Anyways, so since you are not responding, I'll guide you. At zero point 0.5 megapascal, the enthalpy of saturated vapor is 2748.1. Since the given enthalpy 2890 is greater than Hg, you are basically in the superheated vapor region. Kindly recall the slides for the last week so that you identify the region. Plot this, we'll come to know that we are talking about a pressure of zero point 0.5 megapascal where Hg value is this and H is greater than Hg. That means you are lying in the superheated vapor region. This means you have to go to which table? Table A6, which corresponds to superheated. So you'll go to superheated vapor table, and in the superheated vapor table, you will identify the pressure as zero point 0.5 megapascal. And once you go to zero point 0.5 megapascal, the first column is of temperature. Then the you have table zero point 0.5 megapascal is written on the table. There is a line. Then you have this temperature column. The first value is for saturation. Then you have other values 200, 250, 300. These are temperature values. Here you have another column where it is written specific volume, internal energy, enthalpy, and entropy. Under enthalpy, you would find out the value of 2890. You locate the value of 2890. The problem comes when the exact value 2890 is not given in the uh, superheated table for zero point 0.5 megapascal. So I'll highlight the values. Once I go to table A6, I'll highlight the pressure zero point 0.5 megapascal, and in that table, I have selected the value H, which is basically encapsulating the value of 2890. That means 2855.8 is a value given in the table, 2961.0 is the value given in the table, and I have marked their corresponding temperatures, which is 200 degrees and 250 degrees. 2890 lies somewhere in between these two values. I have selected these two values, because 2890 lie in between these two values, and the temperature for 2890 is not given. So I'll have to linearly interpolate. Interpolate means you have to take the average to find out the value corresponding to 2890, the temperature value. So I'll prepare a table of this sort, interpolation table, which says that the values given to me are, this value is given to me from the table. It is 200 degrees. You have the enthalpy value of 2855.8. For 2890, the temperature is unknown, but it is somewhere between 200 to 250. And for 250, the value given to me is 2961. Uh, Are you with me? Do you understand why I have taken these two values, 2855.8 and 2961.0? Do you understand that?
Yes, sir.
All right. Now, linear interpolation means that, let's say if I take this region of the line, let's say I take this line, I know that for 200 degrees centigrade, my enthalpy value is 2855.8. And I know for, let's say, 250 degrees centigrade, for this value, my enthalpy value is 2961.0. There is some temperature value T for which the enthalpy is 2890. So what I'll do is that I'll use these values to construct this ratio. Left hand side, you have all the temperatures. On right hand side, you have enthalpies. And how I have constructed the table, I have taken 250 minus 200. So I have taken 250 minus 200. And on the right hand side, I have taken the enthalpy values corresponding to temperatures. 2961 minus 2855.8. And then I have divided and with again left hand side by the temperature difference, which is T unknown minus 200, T unknown minus 200, and similarly the enthalpy values corresponding to these two temperatures, which is 2890 minus 2855.8. This is nothing but simply the taking the gradient, constructing that the gradient of the line is same, and I've taken the ratio. This equation would give me a value of T, which would lie somewhere between 200 and 250, and this would be the interpolated, linearly interpolated value for the temperature, which comes out to be 216.3. So the value is between 200 and 250, and this comes out to be 216.3. And this corresponds to the enthalpy value of 2890. Is this point clear to you?
Yes, sir.
All right. Moving on, we have another example. Again, in this case, we have been given the region. We have been asked to find out the internal energy of compressed liquid. So we know the region at 80 degrees centigrade and 5 megapascal. Number one, using the compressed liquid table, and number two, the saturated liquid data. Part B is the approximation that we learned. So if 80 degrees and 5 megapascal are given, the conditions are given to me. This is the condition. 80 degrees, 5 megapascal line, you have to find out the value first from the compressed liquid, which is table A7. Now, if you go to table A7 for the compressed liquid, the first thing is you will find out the pressure corresponding to the state given to you, which is 5 megapascal. Pressure is 5 megapascal, and the temperature correspondingly is 80 degrees centigrade. So the value of internal energy corresponding to this condition would be 333.82. This is finding the exact value from the compressed liquid table. In case you don't have the compressed liquid data with you and you have to go with the approximation says that internal energy can be approximated as the saturated liquid value of internal energy at the given temperature, which is 80 degrees centigrade. In that case, you will go to which table? You'll go to table A4, find out the table, sorry, table A5. You know that the saturation temperature is 80 degrees. Sorry, this table would be table A5. You will find out for the saturation temperature of 80 degrees centigrade. Now, if you go to the saturation temperature column, you see that 80 degrees is not given to you. It is 75.86, 81.32, and so on and so forth. 80 basically falls between these two temperatures. So you'll again do the interpolation. You'll construct the table for saturated temperature and saturated liquid internal energy. So you have these values given to you, 75.86 is given to you, and the corresponding internal energy is given to you. The saturation temperature 80 degree centigrade is given to you. Internal energy is not known to you, and this is the upper limit for the temperature and internal energy that you extracted from table A5. Now again, you have to do the interpolation. How would you do? You would do in this way: 80 minus 75.86. On the right hand side, you'll write the same values: U minus 317.58 corresponding to the temperature, 81.32 minus 75.86. Again, you will write down the corresponding internal energy values for the two temperatures, and you will find out the value of U to be 334.97 meter cube per kg. Is it clear? Is the problem clear to you?
Yes, sir.
All right, moving on. We'll look into the last uh, example for this 1 hour class. We'll have one more example where you'll have to do double interpolation, but we'll look into it in the next class, which is on Wednesday, and we'll also look into how to solve the same problems that we have done using these tables uh, by the means of WES software. So we'll go through the problems again on WES software in the upcoming class on Wednesday. So for this class, this is the last example that you have to do, that determine the mass of air in a room whose dimensions are 4 meters by 5 meters by 6 meters. The pressure in the room is 100 kilopascal and the temperature is 25 degrees centigrade. How can you find out the mass of the air in the room whose dimensions, pressure and temperature are given to you? Any idea? You will consider
और फार्मूला
which formula, sorry?
सब वॉल्यूम कैलकुलेट कर लेंगे और प्रेशर फाइंड है और
How would you find it out? You would use, you
या
would consider, Ji, sorry? You would consider air to be an ideal gas and you'll apply the ideal gas relationship which says PV equals to mRT. Now temperature is given to you, volume is given to you in the form of dimensions, pressure is given to you. R is the value of air that you will take from table A17, which is for the ideal gas properties of air. And the only thing left unknown would be the mass. Now, remember in this relationship, you are talking about absolute values. Temperature should be the absolute temperature. So table A1, A1, you would go and find out the gas constant of air, which is R equals to 0.287 kilopascal meter cube per kg per Kelvin. Why you are taking in kg? Because you are taking the specific gas constant for air. So now the absolute temperature is 25 plus 273, which is 298 kelvins, and the volume is just the multiplication of the three dimensions, and the pressure is 100 kilopascal. Once you solve this, you will find out that the mass of the air within the room is about 140 kgs. Clear enough? Is it clear? Yes, no?
सर आपने वो जो गैस
Yes, sir.
कांस्टेंट निकाला है वो टेबल से निकाला है सर
जी
सर
गैस
ये
कांस्टेंट जो है you will go to table A1 and you'll find out the gas constant of the air. Now since you are referring to the specific gas which is air, you will find out the gas constant for the air. All right, you'll not use the universal gas constant which is Ru, which is given in terms of kilojoules per kilomole Kelvin. So you'll not use this constant. All right.
सर ये आइडियल इक्वेशन जो है इसमें एमआरटी हमने नहीं पढ़ा था, एनआरटी पढ़ा था, जिसमें नंबर ऑफ मोल्स का हमें बताया
Beta, were
गया
you sleeping in the last class
था।
where we discussed that when do you have to use PV equals to N जो आपने पढ़ा है that is PV equals to NRUT, where RU is the universal gas constant. Whenever you are using the ideal gas equation for universal gas constant, you will use it in moles. Whenever you are using the ideal gas equation, PV equals to mRT, M refers to mass and R refers to the specific gas that you are talking about. We have covered it in the last lecture. Kindly go back and recall the lecture. All right.
Okay, sir.
All right. So I'll stop over here.